All right, welcome back to The Explainer. So today we're diving into a huge question. How is humanity planning to not just visit the moon, but to actually live there? And the answer is kind of surprising. It's not in some far-out futuristic lab. It's in an instruction manual we've been perfecting for decades, right here on Earth.
I mean, think about it. The whole point of the Artemis program is a permanent moon base. But that creates a challenge of, well, monumental proportions. In an environment with absolutely zero chance of rescue, what do you do when something breaks? And things will always break. You can't exactly call for roadside assistance up there.
And you got to understand, this is a totally new kind of problem we're facing. This is not just Apollo 2.0. We are talking about a complete fundamental shift in how we think about space exploration and engineering.
Okay, so this is where you really see the difference. Apollo missions were basically sprints. They used amazing tech, but it was designed to work for just a few days and then, well, get tossed. If a critical part failed, the mission was scrubbed and they came home. But Artemis is a marathon. We're talking about systems that have to last for decades, not days. And that means you have to be able to fix things right there on the spot.
So, where in the world do you even start looking for a blueprint for that kind of long-term reliability? The solution isn't some brand new, unproven tech. It's a philosophy that's been perfected in an industry that most of us use without a second thought. That's right. Believe it or not, the key to living on the moon comes from the exact same meticulous logic that makes flying in a commercial airplane one of the safest things you can possibly do. It's a system designed from the ground up to keep incredibly complex machines running safely for millions and millions of hours. Okay, so here's the secret sauce. It's called Maintenance Steering Group 3, or MSG3 for short. It's the absolute gold standard in the aviation industry. And the whole idea is to shift from a reactive mindset of we'll fix it when it breaks to a totally proactive one of let's predict and prevent it from ever breaking in the first place. And the logic behind it is actually pretty straightforward, but it is incredibly powerful. First, you figure out what the most important systems are, the stuff that absolutely cannot be allowed to fail. Next, you analyze every possible way it could fail and what the consequences would be. And then you build a smart plan to stop that from happening, either by checking it constantly or replacing it before it even has a chance to wear out. And this quote, man, it just nails the philosophy for the moon. When you don't have a warehouse of spare parts just an overnight flight away, you have to rely on your technology to be your eyes and ears. It needs to constantly monitor itself, diagnose problems, and predict issues before they turn into a catastrophe. Yeah, the system basically has to be self-aware. Now, obviously, you can't just take a system designed for Earth and, copy-paste it onto the moon. This proven logic has to be seriously adapted to survive in one of the most hostile environments we know of. See, the moon forces this logic to evolve. Redundancy, having backups for your backups, isn't just a nice-to-have. It's a survival imperative. You've got that lunar dust, which is like microscopic shards of glass that gets into everything. You've got a hard vacuum. You've got insane temperature swings. All of this forces a complete reliance on predictive maintenance, all built around one stark reality. You are on your own. No one is coming to help you.
And just look at this comparison between the ISS and Artemis. It really hammers home just how big of a leap this is. On the International Space Station, a resupply ship is, at most, a few days away. On the moon, we're talking months, maybe even years. The lunar base will be empty for long stretches of time. So something that's a routine repair on the space station, for the moon, that's a full-blown mission-critical event that has to be planned for way in advance. So how do we actually do this? How does this philosophy work in the real world, on the surface of the moon? Well, it's powered by a whole suite of advanced technologies that act as our eyes, our ears, and even our hands. Let's look at the toolbox. You've got AI diagnostics that basically act as the habitat's central nervous system, always looking for tiny faults. You have robots doing the dangerous external checks for dust damage, which is great, but they can struggle moving around in that loose lunar soil. And down here, structural health monitoring sensors are like a permanent stethoscope on the habitat's hull. But maybe the coolest tool is the digital twin. It's exactly what it sounds like, a perfect working virtual copy of the real hardware, letting engineers on Earth simulate failures and test fixes before an astronaut ever has to pick up a wrench.
And this is where the rubber meets the regolith, I guess. It's where all that tech gets applied to solve real lunar problems.
For the habitats that companies like Lockheed Martin and Icon are designing, it means robotic inspections of different zones to look for wear and tear. For the rovers from folks like Astrobotic and Intuitive Machines, it's about having them run their own diagnostics to check for damage from the vacuum. It's a whole ecosystem built on predicting and preventing failure. You know, at the end of the day, this is about so much more than just keeping the lights on. This entire field of reliability engineering, it's literally the foundation for everything we want to do beyond Earth. If there is one thing you take away from all this, let it be this. By solving this one enormous problem of long-term reliability, we unlock everything else. We make real scientific discovery possible. We can start using resources we find on the moon. We can build a truly sustainable human presence there. Take a look at this number. $170 billion. That's what experts think the lunar economy could be worth by 2045. And that entire economy, every single dollar, is built on the simple principle that our technology has to survive and thrive in an environment that is constantly trying to tear it apart. So whether we're talking about mining ice to make rocket fuel or building permanent habitats in power grids, literally none of this gets off the ground without that core philosophy of maintenance and reliability. It is the critical layer that enables our entire future off this planet. It's a pretty wild thought, isn't it? That sometimes the biggest leaps into the future don't come from inventing something brand new out of thin air, but from looking at the brilliant ideas we've already perfected right here on Earth and just adapting them for the stars.